Welcoming you all again to this session on 3D Graphy News. Myself, I'm Dr. SHIBU John. I'm the managing editor and founder of 3D Graphy News, and also the consortium 3D Graphy. 3D Graphy is a platform, ladies and gentlemen, that we've been able to initiate last 8 years. A consortium which consists of doctors and surgeons and scientists and material scientists and experts in design, 3D metal machines, 3D SLA, SLS, 3D visualization, and also software and simulation. More importantly is also materials, ladies and gentlemen, because that's the final constitute in terms of what can be generated in the course. So others are all tools. So it's been a great time for us to have built this over the last 8 years, so that anything to do with an information can always be clicked and retried, or it can also be on a physical contact of all our members who are registered with us. And the conscious effort was to see that starting in India, this kind of a consortium was very, very essential and important for us to work with experts as well as aspirants who come with a clear intention of learning the technology. So this becomes a one-stop solution for everybody to know who is the right respondent to connect with. So it becomes an exchange of information and connecting with the right course in terms of taking the course forward. While that has also been our conscious effort, we also believed in communication. So in terms of promoting technology, so 3D Graphy ShopMart is also an initiative that we initiated last 2.5 years back, and we structured it with a clear intention to see that 3D technology companies can showcase their products and solutions on a platform where people can actually get in and then get these information of these machines and technology. Because ladies and gentlemen, our conscious effort is democratizing 3D technology to benefit all. That's our motto. And also starting with a clear intention this year, this being our 8th year, we want to take the course to the next level. Because it's important that 3D technology needs to gain that kind of attraction and penetration across the country and globally. Globally, it was always accepted, but yes, I'm saying the opportunity still remains, because every now and then we see a new development happening when it comes to innovation in materials or the technology or likewise. So having an information source is also very, very important, ladies and gentlemen. So that's the reason we also understood in the COVID times that digital space is a great space to be in, because prior to the COVID, we used to conduct physical events, and that was almost 20 events that we did, but that was 6 years in our span of time. But in 2 years, we managed to do close to 24 events. So that's overall coming to 44 events that we've done in the last 8 years. So we realized the importance of digital, so that the information source is also shared and connecting with the right course and right people, and also getting to learn what is happening new. So that's the reason 3D Graphy News got initiated, with a clear intention of experts' opinions and also coming from end users, both 3D technology companies, researchers, material scientists, and also people who are doing some great work in creating new paradigm in terms of creating new opportunities in the space. So today I have a great opportunity and privilege to introduce you to Dr. Ravi KR, who is the Associate Professor, the Department of Metallurgy and Materials Engineering from Iit Jodhpur. Doctor is an Associate Professor, as I mentioned, for Iit Jodhpur. He's also completed his BTech in Metallurgy Engineering at Madras University. He completed his PhD in Metallurgical and Material Engineering at Indian Institute of Technology, Kharagpur in 2009. Doctor works in the broad areas of additive manufacturing, computation, thermodynamics in alloy design, biodegradable magnesium alloys, and self-cleaning coating. So he comes with his expertise, and we are so proud, Doctor, for the recent development in terms of also creating this indigenous research-based DD machine in your institute with your team. And thanks for this opportunity. Doctor, I may quickly want to then ask you in terms of where it all started, in terms of the journey, though we understand your background, but why DED and where the idea struck to you, sir?
Yes. See, actually, after completing my postdoc, I was there in IIT Madras as a postdoc for 2 years. After completing that, I joined PhD institutions as an assistant professor. It was a multidisciplinary group I was working, and during that time, I had an interaction with the Dr. Professor Radhakrishnan. He's pioneering manufacturing. So he actually saw one of my presentation about functionally graded materials. Then he started discussing about why don't we think of working in this particular area, because he had interest in doing the functionally graded material through this metal AM machine. In fact, PSG started the Tifaco Center, I think, in 2001. So they have been doing excellent work in 3D printing area, almost like last 22 years as a service provider, and doing a lot of work for industries and medical, aerospace, and many kind of applications they were doing. But most of the things are on polymers. So Professor Radhakrishnan had an idea of like we should work on metal. That too had an intention of building machines. He used to say that yes, those time machines were actually mostly imported. Most of the machines are like what you call like it's not like open machines. You cannot change material. It is not open machine. So he said if you want to change parameter, if you want to develop new materials, or if you want to develop certain new products, the machine should be open. So that's where he said we should work on why don't we actually develop our own machine. So being a metallurgist, I was a little bit, I was not very confident that how come a metallurgy person can actually build a machine. That's where we had like continuous interaction with Jyoti Majumdar, Professor Jyoti Majumdar. He's no more, but University of Mexican. Actually, we used to have a lot of interaction with Jyoti Majumdar in terms of metal AM. Being a metallurgist, he's again he's a materials engineer and metallurgist, and he has done the DMD machine, and he developed the technology. And in fact, he has done completely a closed-loop control machine way back in maybe 2010 that he has done, and I had a lot of interaction with him. So that really inspired me. It's not that only metallurgical engineers also can do this kind of process. That's where actually we had a lot of discussion how to go about it. Initially, we thought of buying machine from DMD machine. Then we had a lot of interaction. And then we also had an interaction with a lot of user industries like defense, aerospace, and we have seen that they were also encouraging us to build a machine because it will become open machines, and it will give a lot of flexibility in terms of doing that. That's how this whole thing was started. We wrote project to DST in 2015, and the whole team was really helped us, and it has gone through several stages. Finally, we got funding in 2019. At that time, I joined Iit Jodhpur. I joined Iit Jodhpur in 2018 September. So that's where part of the money came to Iit Jodhpur, part of the money went to PSG institution. That's how this entire process started, and we started working on this metal 3D printing. Second part of your question is why DPT? Because if you look at in terms of metal 3D printing technology, the market share is almost 80 to 85% for selective laser melting, so mostly powder bed fusion methods, and around 6-7% for electron beam melting, around 10 to 12%, around 13-14% is for DED. Mainly because in DED you can make bigger machines, bigger parts you can make, and you can do multi-materials, especially like functionally graded materials that you can do. The most of the materials we use currently are not meant for additive manufacturing. Mostly it's meant for some other application, like take titanium 6 aluminum 418 alloy. Those are actually meant for aerospace application. Later on that has been used for medical application, but those alloys are really good, but there are alloys which are actually very much prone for additive manufacturing. Most of the time, designing new alloys which are very easily can be done in DED manufacturing, DED 3D printing compared to other process, because most of the alloys what we use are meant for some other application. So take Inconel 718 and titanium 6 aluminum 418 alloy. Those are meant for really for aerospace and defense application. Later on, people start using those alloys for implant application. But there are better alloys. There are alloys which are highly amenable for 3D printing process. So developing that kind of alloys are possible. Theoretically, you can do by computational thermodynamics or graphite approach, you can do that. But experimentally, how do you validate that kind of new alloys? So in DED process, you can actually have multiple hoppers and multiple powder feeders. You can develop a new alloy in a print. In single print means in a 20-25 samples with a different composition that you can print, so that your screening of alloys are possible. Your designing alloys can be done much faster. That's where DED plays a very, very important role. Apart from that, DED plays a significant role in the repair manufacturing. That's where other technologies, because in other technology you have to start from the flat platform. In DED you need not to have a flat platform. You can actually broken parts from the broken parts. You can start printing. So that where DED has its own advantage. I would say the way that we look at additive is not going to replace subtractive manufacturing. Never. It has its own areas of application. Subtractive has its own area of application. Similarly, additive has its own area of application. Same way, if you look at EBM, SLM, and DED has its own area of application. So it's not going to compete with SLM. So it is a complementary technology rather than a competing technology.
Very true, Doctor. So every technology in 3D technology has its own areas of specialization where they can really be utilized well for the larger interest for each of these sectors. So, Doctor, now that you have been able to formulate this machine, how do you want to take this to to the larger audience for making it more commercialized? Have you also thought of something on those lines? Or
Yes. See, actually, objective of this entire project is to say that so we know about polymer 3D printing for the last 30 years, and metal 3D printing started 25 years. But you can see the reach, almost the polymer 3D printing reached to the commercial machines, and a lot of products are coming out. In terms of metal 3D printing, I would say it's more of a research and development stage. Okay, mainly because of one thing is that it has a lot of parameters one need to understand. You have to play with it, and it's not easy for let's say even if I make a machine, I give it to industry, they cannot actually make a part because you need a highly skilled manpower. So our interest is to see that actually you make it a machine much more simplified using this recent technologies like automation. Through automation using AI and ML, somehow we minimize the human intervention as much as possible. So see that you can actually make these machines. At least it may not be a completely unskilled person. At least semi-skilled person should start operating. That's where actually we wanted to take up this particular technology. That's where now we are actually working on. Okay. So in terms of commercialization, yes, currently we are discussing. I think this project is funded by DST's Technology Development Program. In fact, they also even recently they called us and why don't you commercialize this technology? Yes, we are discussing with some of the industries. We have a plan. We can actually transfer this technology. Our intention is to see that it is affordable by some of the MSMEs which cannot invest larger money. So we wanted to make it as as cost effective as possible. So by making make use of the tools available in India, so that we can actually minimize the total cost of the machine. So that's another thing. And again, we wanted to use the powders. Powders are one of the major challenge in additive manufacturing. So we try to use most of the powders for our machine mainly sourced in India. So that's where also I think more players. Now currently, IndoMM is one of the leading industry who is manufacturing this metal 3D printing powders. Maybe in over a period of time, I think you hopefully will see that more powder manufacturers come with aluminum and titanium or the alloys really wanted to. That's where we are looking at. In terms of commercialization, yes, we cannot do a startup. I think it will be too risky to invest in this area. Maybe like we can give the technology, transfer the technology to some of the industries. DST is ready to fund those industries. That's what they told us. Like they will fund those industries so that they can actually do the commercialization part. So that's how we are actually looking at it. So that's what the intention of this project also.
Right. And also making it more simplified, Doctor, as you rightly mentioned. As you progress, you're also trying to simplify the machine for making it more user friendly. So democratization of 3D technology itself is being seen here in terms of the larger intent for you to see that how it can be simplified, how cost efficient it can be, so that everybody can use it to the larger interest for sectors and industries to benefit, and the country benefits at the large. So that's a great initiative, sir.
Also, one more thing I would like to add here. See, now currently, if you look at alloys, commercial alloys for metals, we have 5,000 alloys for different applications. But if you look at for 3D printing, hardly we have 10, 15 alloys. Each alloys will take at least 3 years to optimize the process parameter for a particular machine. So if we actually include all those automation process, this process can be cut down maybe in 5 to 6 months. That is one advantage. Okay. What about the lifetime of person? If I work, I can develop. If it is 3 to 4 years, and I can develop probably 2 to 3 new alloys in my whole lifetime. If we cut down the time requirement for the optimization, 3 to 4 months, that means one thing is bringing down the cost of the machine. The more users will come into the picture, and bringing down this total time for optimization will bring it down. More people means same person can do optimization of many materials. So that way it will become, as I said, it's a democratization of this whole technology coming to picture. So it will close means it's like polymer 3D printing, metal 3D printing also will flourish, and we'll start seeing a lot of product coming out based on this technology.
Yes, and also, very true, because we need more products and more IPs when it comes to creating IPs in the country to, in this space. Doctor, just also wanted to understand now, this is a wire arc technology that you are currently, been able to formulate, or also spray technology, because we have both the technologies.
Indeed, this currently what we are doing indeed is a powder feed technology, where we feed the powders and laser actually melt the powders. So this machine can be extended for wire also can be fed. It's not arc; it is laser-based process.
And also, when you discussed about the potential of even democratizing here is also in terms of offering services. So while the research is also being done with new materials, you can also offer services to the industry to begin with. So are you also in that process of doing it?
Currently, we are not. No, currently we are not, because this is a funded project. We have to see that whatever commitment we made for the funded projects, we have to complete. So beyond that, I think we can actually start offering the service. So that way, I think the technology will be flourished and more people can use this technology. So we have intention, but it may not be a commercial aspect. So that's where we have restriction, because we cannot take money from anyone and sell the parts. So that I think that has to be done completely differently. So not in this project.
Also for institutions, doctor, like DRDO and DRT, and likewise ISRO, is that this opportunity is also open for them?
Yes, surely it is open for them. Already we have some collaboration with the ISRO. So surely we'll be working with the institute like DRDL, DMRL. We had some discussion, so we can actually offer service to them. So that way it will be very useful for. We also will come to know that the capability of the equipment, where it can do, means where it has restrictions. So that way, once we start making more components, then it would be like a service providing service that would also help us to understand the limitation of this equipment. Also. It's not like only the strength. We also have limitation of every technology. Every equipment has its limitation. So we also can understand what is the limitation, how far we can go, what exactly the level we can actually go for. Get into using this machine, how far we can reach.
One more thing is, doctor, now that you have been able to formulate this technology, are you also open to having more institutes also working together in terms of even the students who would want to pursue and learn the subject through the incubation center? Do you also look at that kind of an opportunity?
Yes. Actually, we have a technology incubation center here. So we also take Indian students from other colleges. and students from in our room from different departments they come and work here. So that way, I think we are also asking the colleges nearby, MBM college and other colleges, we are asking them to come here. That is also part of like currently I have one more SERB project. That is part of that project is we need to have intensive to many students and we need to conduct workshop and we should see that more users are coming, more students are coming here and use these machines.
You also have PhD courses for students who want to pursue in this particular area of additive manufacturing, specifically to do with DED?
Yes, so we have a PhD program. Currently, with me, 5 PhD students are working with this DED technology, metal 3D printing. So we'll be interested in taking more students in this area, especially towards automation, like using AI and ML and sensors, and make this process completely what do you call it? It's like a closed loop feedback control is the kind of technology that we would like to incorporate. Being an open machine, we know how to incorporate, where to incorporate, how to attach sensors in different locations and get the data. So that's how we wanted to take up this technology for the next few years.
So one good statement, now that we know that the government is also supporting the initiative for with the new initiative from the government. I mean, not the new initiative, it's been a long time that we have been able to announce for Atmanirbhar Bharat. Where do you see this helping you, Doctor, when it comes to, I'm sure with the funding and grants that you're getting from DST, what is your thought all about in terms of seeing, how this is actually helping institutes like you and also experts like you who've been really working in terms of research going forward, and how does it really help for the country going forward?
See, actually, now if you look at the funding pattern, earlier, maybe in 10 years back, when I started my research career, most of the funding were given for fundamental research. Now it has been drastically cut down the funding for fundamental research, mainly the product-based research. Okay, so now we need to show product and we need to show some proper physical deliverable to get a really good funding. That means a big funding that we need to do. So I have seen that last few years, a lot of funding for startup, a lot of initiatives for startup. So means the amount of funding reaches in several crores. That way, more people would come and do this, take up this startup and do incubation and work with us and developing novel technologies. So that way, I think the initiatives made by the government in the last few years are really helping. I've seen that even in this our technology incubation center, within a year, we could see around 20-25 people are part of the incubation center. So many of them are already converted into startup. So that way, it is a very wonderful thing which is government has taken a few years. So we also have some program in medical technology. So that's where actually our intention is to make medtech product in the area of medical domain. Actually, we have a joint program with Iit Jodhpur. So there also our intention is to create startups. Means we wanted to have incubation center where we have incubators, and we wanted to see a lot of startups come into the picture. So that way, I think all these initiatives would really help us, and especially like this said, sensors. Many startup can. It's not like a huge investment. You can have with a small investment, they can get a. For 1.5 years, they can, let's say you spend, you put around 5 lakhs and you can get a product which you can sell it around 20-25 lakhs by doing research for 2 years. So that way, it is a really useful initiative by the government. I think a lot of things can be done in this area.
Also, Doctor, you mentioned about AIIMS Jodhpur. Now, this technology can also be used in medical. I understand it can be used in aerospace and shipbuilding and various other huge parts. But where does this actually? Where would this be benefiting in terms of the medical space, Doctor?
See, medical space, when you look at implants manufacturing required 2 aspects. One is the machine should be certified, means in terms of it has to go through that all the process. Again, a material has to be certified. Okay. So currently, yes, our machine is not certified, and the materials we can buy material which is certified materials we can purchase and we can use it. But that will take some time. But especially for custom-made implants, yes, it can be done. using this particular machine. It's custom-made machine. You need not to go through exhaustive, what do you call this, process like
approvals, medical approvals, certification.
Medical approval. Yes, certification and approval is not very exhaustive. So the custom-made setups we can do. But really for other applications like where you don't really have the interaction between these human body tissues and other things or cells interaction like pictures and other things for medical where you really need parts means pictures immediately. So those places this particular technology can be used, especially repair manufacturing. This can be used. But implants we have to be we need a lot of works to be done to get approval for both machine and materials.
Doctor, one good statement that you have in mind that you want to share on the platform. A statement coming from you in terms of the technology and for the good work that you've been able to do, and how does it translate to value? One good statement.
Yeah, one good statement. See, if you want to do anything, it's not only for this one. If you want to do anything, you need first money. Okay, you need funding. Just funding is not enough. 10 crore, but if you don't have a great idea, it is not going to work. You need a very great idea to use that money, effectively use that money. Then next thing is you need people who can understand the idea and should be execute at the level. So if you have all these combination, only it will work. Just having money, it's not going to work. Just having great idea, it is not going to work. Whatever you may have money, you may have ideas, but the people who works at that soft floor or maybe a student, they should also need to understand. They should also have to have a passion to do that. Whatever that you have, only then it will work. That's what I understood from these last 2-3 years working with my PhD students or working with funding agency. Is that with a limited fund, with bright ideas and with very good students, you can make things which you can only dream in your dream. That's what.
Very true, doctor. I mean, all of these aspects are very important. Financial support, also an idea with the passion, and also a team. So very, very important, doctor. But it all starts with an idea, and also passion, which has actually come from you, doctor. And thank you so much for your time, and wishing you all the very best and congratulations. And great thing that you've done, doctor. It's a very commendable task and for you to have achieved. And wishing you all the best.
Yeah, just one more thing I wanted to add before completing this particular interview. So this particular press release came after actually we were actually doing everything closed doors. Actually, we were not actually showing to everything outside of the world. And we had we had an open house in Iit Jodhpur, I think 3 months back. That's where people came, all the people in Jodhpur came to Iit Jodhpur, and they saw some of the people came to our lab and they saw the equipment. That's where it got a news came outside community. That's where they were asking us to why don't you do the press release. That's how it came into the picture. One thing that I would like to tell here, see many things written in the press. Okay, many things written in that thing. Actually, this is the first time in India. It is not true. Okay, we are not the first. I think people have done. I think there are many people have done. I think they are in a very different stages. People have done. We are not the first. Then in the press it says 10 crore machine made in 5 crore. Someone said 5 crore made in 1 crore. It is not. It is not true. It is not our statement. Actually, what I said is, if everything can be manufactured in India, we can cut down the cost maybe from 2 to 3 times. It is not like it is my own statement. These were the things I wanted to clarify, because what we say with some intention, the media completely project it in a different way. So, because as a researcher, if someone says that someone else says that I'm the first person who did this technology, then we get that. That's what happens. So
that's not right, and also to publish it, doctor. I mean, nowadays, media is also taking the course in terms of publishing things which are not true, which is not right, and that's why we also thought these personal interaction and as a virtual platform like these can be so effective. Because the message is delivered rightly, and it is coming from the right respondents, feedback. So thank you so much. I mean, I really appreciate your time and for the good work that you've been doing, doctor. And but it's a great achievement, and we really acknowledge it. and for the efforts made, Doctor. All the very best.
I also thank 3D Graphic News for giving me this opportunity to convey my information, which what I would like to, with whatever is there in my mind, I would like to convey so that audience also can understand. Okay.
Right. Yeah. Thank you, sir. Thank you so much for your time. Thank you so much for your time, and all the best. Thank you.